The United States leads the world in its top 10 cutting-edge technologies. With its advantage rooted in technological accumulation, industrial synergy, and high R&D investment. However, intensifying multipolar competition, coupled with challenges like talent drain and soaring costs, has gradually narrowed this lead. The technological race has now entered a new phase of multifaceted competition. Late at night in the Technology Exhibition Hall, a massive circular screen scrolls through dynamic visualizations of global industrial transformation. A set of constantly updating comparative data in the corner catches the eye. Among the top 10 technology fields by global R&D investment share, the United States holds 6 positions, yet its lead in 4 of these fields is projected to narrow year-on-year by 2025. As fingers trace the flickering tech nodes on the screen, a thought-provoking question emerges. For this nation long standing atop the technological wave, are the core technological keys it holds a solid foundation of hegemony, or a fragile fortress now facing the impact of multipolarity? Assessing a nation's strength should not be swayed by emotion but rooted in objective reality. While the United States retains significant influence over core technologies, it faces formidable challenges from multipolar global competition, compounded by brain drain and soaring costs in certain industries. Next, we embark on a deep exploration journey through the veins of technology, unlocking the true competitive codes of America's top 10 cutting-edge technologies. Stepping into the chip R&D zone, microscopic chips resemble intricate urban labyrinths under magnifying glasses. This is the powerhouse of the fourth industrial revolution, the semiconductor industry. Every smart device worldwide relies on this maze for its operation. The exhibition's division of labor map clearly charts the global semiconductor industry's collaborative landscape. European firms steer the R&D compass for semiconductor equipment, with companies like SML and Applied Materials commanding over 70% of the global market share. Japan serves as the core materials supply base, with Japanese firms commanding over 50% of the global market share in critical materials like photoresist and high-purity wafers. Taiwan and South Korea shoulder the primary manufacturing and processing responsibilities, with TSMC and Samsung dominating over 90% of the global advanced process chip foundry market. Yet the true lifeline of this maze remains firmly in American hands. Much like how urban core planning rests with designers, the global market for EDA core software essential to chip design is monopolized by 3 American firms: Synopsys, Cadence, and Mentor Graphics, with a combined market share exceeding 95%. No advanced chip design process can bypass their technical support. In the chip manufacturing process, American companies hold over 40% of core patents, ranking first globally. ASML, the lithography giant, resembles a castle built through multinational collaboration. Its equity is dispersed, and its core technologies involve diverse participants. Its most advanced EUV lithography machines contain over 100,000 components sourced from multiple countries worldwide. However, critical core components like light source technology and precision control systems see deep involvement from American companies through patent licensing, securing the U.S. a firm grip on key entry points in the supply chain. Today, dynamic models within the exhibition space simulate the ongoing restructuring of the U.S. semiconductor industry. Global production segments, resembling migratory birds, are gradually converging toward American soil. This realignment is not coincidental but an inevitable outcome driven by the U.S. CHIPS and Science Act, enacted in 2022. The CHIPS and Science Act allocates $52 billion to support domestic semiconductor manufacturing while establishing a $24 billion investment tax credit to attract global chipmakers to build factories in the U.S. By the end of 2025, TSMC's Arizona facility will complete its first phase of construction, representing a $40 billion investment focused on producing 3-nanometer process chips. Samsung's Austin facility also announced a $20 billion expansion to boost advanced process capacity. This strategic layout has been incorporated into the Pentagon's FY 2025 microelectronics manufacturing investment blueprint, with the Department of Defense allocating $8.5 billion in dedicated funding for the sector to prioritize technological synergy between domestic chipmakers and the defense industry. However, this industrial restructuring faces significant headwinds. Risk warning panels beside dynamic models reveal underlying concerns. First is cost pressure. TSMC's Arizona facility construction costs exceed Taiwanese counterparts by over 30%, with soaring labor and land expenses amplifying corporate profitability pressures. Second, a shortage of skilled workers persists. A 2025 report by the Semiconductor Industry Association (SIAL) indicates a gap of approximately 60,000 skilled workers in the U.S. semiconductor sector. Despite joint government industry vocational training initiatives, this deficit remains unbridgeable in the short term. More critically, the collaborative nature of the global semiconductor industry complicates the full implementation of related plans. In early 2026, the U.S. Department of Commerce granted annual licenses to TSMC, Samsung Electronics, and SK Hynix, permitting these semiconductor giants to continue importing U.S.-made chip manufacturing equipment for their Chinese facilities. This move underscores the U.S. semiconductor industry's deep reliance on the Chinese market. Data reveals China is the world's largest chip consumer, accounting for over 35% of global chip consumption. Severing ties with the Chinese market would cause significant revenue declines for U.S. chip companies. TSMC's Nanjing facility primarily manufactures mature chips using 16 nanometers and 28 nanometers processes, with a monthly capacity of approximately 20,000 12-inch wafers. While not cutting-edge technology, these chips serve critical sectors like automotive electronics and the Internet of Things, making the plant a vital component of the global supply chain. The U.S. shift from unlimited exemptions to an annual approval system reflects a dilemma, maintaining regulatory control while avoiding complete severance of commercial interests. This predicament vividly illustrates the deep integration of the global semiconductor industry. Turning away from the chip exhibition area, we arrived at the health station dedicated to life sciences. Every exhibit here is intimately connected to human health and well-being. From precision medical diagnostic equipment to breakthrough innovative drugs, each showcase highlights technology's protective power over life. Display boards introduce the world's leading medical institutions and enterprises. A casual glance revealed that over half of the top 10 medical schools, top 10 hospitals, top 10 pharmaceutical companies, and top 10 medical device giants as ranked by global authoritative bodies bear the American emblem. Pfizer and Johnson stand as guardians of health, combating disease with advanced pharmaceuticals. Pfizer's research breakthroughs in COVID-19 vaccines and oncology treatments have benefited the world. In the first half of 2025, Pfizer's oncology drug revenue reached $12.8 billion, accounting for 35% of the company's total revenue. Johnson & Johnson excels in both medical devices and consumer goods, holding leading global market shares in orthopedic implants and minimally invasive surgical instruments. Mayo Clinic and Massachusetts General Hospital function as sophisticated health monitors, safeguarding lives through cutting-edge medical technology. Mayo Clinic has ranked as America's top hospital for a decade, offering globally leading solutions in cardiovascular and neurological disease treatment, attracting patients from over 120 countries annually. MGH's research prowess is equally formidable, ranking among the world's top medical institutions in annual medical publications. Its breakthroughs in frontier fields like gene editing and cell therapy continually push medical boundaries. Abbott's exploration in genetic medicine resembles decoding life's blueprint. Its gene sequencing devices precisely detect hundreds of hereditary diseases, providing core support for precision medicine. America's leadership in life sciences did not emerge by chance but resulted from decades of coordinated development in R&D investment, talent cultivation, and industrial ecosystem building. Data shows that in 2024, U.S. R&D spending in life sciences reached $125 billion, accounting for 38% of global R&D investment, with pharmaceutical companies contributing over 60% of this total. The United States boasts the world's most comprehensive biopharmaceutical industrial ecosystem, spanning fundamental research, clinical trials, and commercial production to form a complete industrial chain. The U.S. Food and Drug Administration's FDA approval system is globally regarded as a benchmark. Its stringent standards and efficient processes ensure drug and device safety while accelerating the market entry of innovative products. In 2025, the FDA approved 56 novel drugs, with U.S.-based companies accounting for 70% of these innovations. Yet a set of figures in the corner of the display panel casts a shadow over this health oasis. The fiscal budget passed by the U.S. Congress in 2025 slashed medical research funding by $4 billion, including an 8% cut to the National Institutes of Health NIH budget. As the world's largest medical research funding agency, the NIH's budget reduction directly impacts the advancement of numerous basic research projects. More critically, a 2025 survey by the American Association for the Advancement of science revealed that over 75% of U.S. life science researchers are considering leaving their current positions, with 30% explicitly stating they will relocate to regions with stable R&D investment. This talent exodus stems from a convergence of factors: insufficient research funding, intensifying industry competition, and soaring living costs. Meanwhile, the landscape of global life sciences fundamental research is quietly shifting. The latest Nature Index research leader rankings reveal that certain institutions have achieved global leadership in both the volume of published papers and citation counts within this field. In cutting-edge areas like gene editing and cell therapy, R&D progress among multinational companies has largely synchronized, with breakthroughs emerging in specific domains. Competition in global life sciences has evolved from a single leader model to a multipolar coexistence. Passing through the house station, the signal ripple model in the 5G communications exhibition area flickers continuously. Blue ripples radiate outward from the center of the exhibition space, simulating the global coverage of 5G signals. As the core infrastructure of the digital economy, 5G communications has become a critical battleground in global technological competition. Yet the dynamics of this race are far more complex than they appear. An information panel explains that while none of the world's three major 5G equipment giants Huawei, Ericsson, and Nokia originate from the United States, all must pay substantial patent licensing fees to American companies. This is akin to vehicles paying tolls to travel on highways. Qualcomm and Texas Instruments stand as the primary toll collectors on this communications highway, holding foundational patents that are unavoidable and account for the highest global share. According to global patent databases, U.S. companies hold 18% of 5G standard essential patents, with Qualcomm alone claiming 12%, the highest share among global firms. This means that nearly every smartphone produced and sold worldwide must pay tolls to companies like Qualcomm. For a smartphone priced at 3,000 yuan, Qualcomm's patent licensing fees alone can reach 150 to 200 yuan. Through patent dominance, U.S. companies firmly control the profit core of the 5G communications industry. Qualcomm's Snapdragon series chips remain the core choice in the global smartphone market. In the first half of 2025, Qualcomm Snapdragon chips held a 65% share of the global Android smartphone chip market, surpassing MediaTek to take the top spot. Texas Instruments dominates niche segments like RF chips and power management chips. 1 in every 2 smartphones worldwide uses Texas Instruments power management chips with its technological edge, making it difficult for other companies to replace. On the other side of the exhibition area, a satellite model showcasing Musk's Starlink project drew significant attention. Thousands of low Earth orbit satellites, resembling stars in the night sky, are meticulously arranged to form an extensive satellite network, reshaping the global communications landscape through a groundbreaking model. By the end of 2025, Starlink had launched over 5,000 satellites, with 4,800 in orbit, covering more than 95% of the Earth's landmass. Its unique advantage lies in its low-orbit configuration, achieving communication latency of just 20 to 30 milliseconds between satellites and ground terminals, far lower than traditional geostationary satellites. This makes Starlink indispensable for remote area coverage and emergency communications. During natural disasters across multiple regions in 2025, Starlink terminals provided immediate communication support to affected areas. Its communication capabilities were widely recognized during disaster relief efforts for events like the Turkey earthquake and the Philippines typhoon. However, the rapid expansion of the Starlink program has also sparked significant controversy. First is the issue of space resource allocation. With limited resources in low Earth orbit, Starlink's mass launches have heightened the risk of orbital congestion, prompting objections from multiple nations regarding its launch plans. Second is the problem of spectrum interference. The spectrum used by Starlink satellites overlaps with terrestrial communication networks, leading to multiple incidents of interference with ground-based communication signals. Moreover, the multi-domain application potential of the Starlink project has drawn global attention. Relevant U.S. departments have signed multiple cooperation agreements with SpaceX to deploy Starlink terminals for communications. The procurement of 20,000 Starlink terminals by 2025 signifies the project's expansion beyond commercial communications into broader domains, further intensifying competition for space resource utilization. Despite ongoing controversies, the Starlink project continues its accelerated expansion. SpaceX plans to launch 12,000 satellites by 2030 to build an even larger global communications network, further solidifying the US's influence in the global communications sector. Moving forward, intelligent robots in the AI industry exhibition zone interact with visitors. Some robots precisely replicate human movements, while others swiftly answer complex academic questions. This space feels like a microcosm of the future, vividly showcasing the powerful allure of artificial intelligence technology. The United States has built a complete ecosystem kingdom in this field. From foundational computing power support to core algorithm model development, and onto upper-layer platform construction and commercialization, it has formed a closed-loop industrial chain. The synergistic effects of this chain have enabled the U.S. to maintain long-term leadership in AI. In the foundational computing power segment, NVIDIA and AMD serve as the power engines of this ecosystem, delivering robust computational support. NVIDIA's H100 and H200 series GPU chips are the core hardware for global AI training. In the first half of 2025, NVIDIA's data center business revenue reached $45 billion, a 180% year-over-year increase, with AI chips accounting for over 90% of chip sales. AMD's MI300 series chips are also rapidly gaining ground, capturing market share through cost performance advantages. Their market share rose to 12% in the first half of 2025. In core algorithmic model development, OpenAI, Google, and Anthropic function as the intellectual brain of the kingdom, setting the direction for algorithmic model and application scenario development. OpenAI's GPT-5 model achieved major breakthroughs in multimodal interaction and logical reasoning capabilities, processing information across text, images, audio, and video formats. Its commercial applications now span education, healthcare, finance, and more. Google's Gemini model excels in multilingual processing and scientific computing, deeply integrated with Google's search and cloud computing services to create synergistic effects. Anthropic's Claude model, centered on safety and explainability, has garnered interest from multiple enterprises, securing $10 billion in funding by 2025 with a valuation exceeding $80 billion. In the realm of commercial implementation, the United States boasts the world's most diverse AI application scenarios. From autonomous driving and smart healthcare to industrial automation, AI technology continues to penetrate deeper into these sectors. Waymo's self-driving taxis have entered commercial operation in 5 metropolitan areas including San Francisco and Phoenix. By September 2025, monthly ridership exceeded 1 million trips, establishing Waymo as the global benchmark for autonomous driving commercialization. Yet the comparative display panels in the exhibition area clearly indicate that the U.S. is not the sole ruler of this ecological kingdom. Global AI development has evolved into a multipolar landscape. Open-source large models from multiple countries have emerged as rising stars, demonstrating global competitiveness in specific language processing tasks and industry-specific applications. They have even surpassed comparable models, shattering the myth of a single-country monopoly in the large model domain. According to the 2025 Global Large Model Capability Assessment Report, open-source models from multiple countries demonstrate distinct advantages in comprehensive scoring across various specialized scenarios. In the computing hardware sector, enterprises from multiple nations are accelerating breakthroughs, with relevant chips achieving scaled deployment and capturing market share in local AI training scenarios, thereby reducing reliance on computing chips from a single country. More notably, underlying the prosperity of the U.S. AI industry lie deep-seated concerns. In 2025, NVIDIA's financial statements revealed a persistent rise in accounts receivable as a percentage of revenue, climbing from 15% in 2024 to 28% in the first half of 2025. This data indicates NVIDIA has begun extending payment terms, allowing customers to defer chip payments, reflecting the cash-strapped reality facing numerous AI startups. The U.S. tech IPO market experienced a surge in 2025. Yet over 2/3 of newly listed tech companies saw their stock prices fall below the offering price. Even star AI enterprises were not spared, as the market began questioning the profitability of AI companies. Moreover, the AI industry's rapid expansion has driven massive energy consumption. Data centers currently under construction in the U.S. are approaching New York City's historical peak electricity usage, while many planned projects still face insufficient power supply. Soaring energy costs are eroding AI companies' profit margins. Tightening regulatory policies also weigh on the U.S. AI sector. The EU's AI Act has officially taken effect, imposing stringent oversight on high-risk AI applications. Meanwhile, the US is developing its own domestic AI regulatory framework. These policies will further standardize AI industry development while increasing compliance costs for companies. Although other nations still rely on the US for foundational computing chips and core algorithm licensing, America's monopolistic advantage is no longer secure. Global AI competition has entered a more intense and diversified phase. Adjacent to the AI exhibition area, the industrial software zone displays models of control hubs for various factories from aerospace, manufacturing workshops to semiconductor wafer processing plants. Each model demonstrates the real-time operational workflows of industrial software, functioning as the nerve centers of these factories. Industrial software directly determines production efficiency and technological capabilities, serving as a crucial manifestation of America's implicit technological hegemony. The advancement of global high-end manufacturing relies almost entirely on the support of American industrial software. Within the industrial software sector, distinct companies occupy clearly defined niche markets, collectively forming a comprehensive monopoly landscape. As a globally renowned industrial software giant, Microsoft's products function like universal neural connectors serving all industries. Its Azure IoT platform enables interconnectivity and data collection, analysis for industrial equipment, with over 50% of the world's large manufacturing enterprises utilizing this platform for production management. Lockheed Martin's industrial code, however, functions more like specialized neural wires tailored for the defense sector. It focuses on the R&D and design of military products like fighter jets and missiles. The code it develops primarily serves specific defense scenarios, differing fundamentally from Microsoft's industry-wide industrial software in application domains and technical standards. The two are not directly comparable, making it inappropriate to judge them simply by code volume. Companies like Autodesk and PTC are nerve specialists in niche markets, holding absolute dominance in R&D and design-oriented industrial software. Autodesk's AutoCAD and Revit software command over 80% global market share in architectural design and civil engineering, with virtually every major global construction project relying on Autodesk software support. PTC's Creo software demonstrates formidable competitiveness in mechanical design, covering the entire workflow from conceptual design to manufacturing. It is widely adopted in automotive manufacturing and aerospace sectors. In semiconductor design, ADA software from Synopsys and Cadence serves as the core foundation. All advanced process chips globally must utilize software from these two companies, whose combined market share exceeds 95%. In industrial control systems, Honeywell and Rockwell Automation dominate over 60% of the global market. These systems are critical to ensuring production safety and efficiency in vital infrastructure sectors like petrochemicals and power generation. The monopolistic advantage of U.S. industrial software stems from long-term technological accumulation and industrial synergy. Developing industrial software requires extensive industry experience. Leveraging their early leadership in global manufacturing, U.S. companies have amassed rich industry data and application scenarios, enabling precise alignment with diverse sector needs. Simultaneously, U.S. industrial software firms have forged deep collaborative relationships with manufacturing enterprises. Software companies can rapidly obtain feedback on manufacturing requirements, continuously optimize product functionality, and create a virtuous cycle. Take the collaboration between Boeing and PTC as an example. Their jointly developed specialized aerospace manufacturing software enables precise design and assembly simulation of aircraft components, reducing aircraft development cycles by over 30%. This synergistic advantage is difficult for companies in other countries to surpass in the short term. Globally, high-end manufacturing sectors like large-scale shipbuilding, semiconductors, and aerospace all rely on these American industrial software solutions. In shipbuilding, Aveva Marine software dominates over 65% of the design software market for major global shipyards, enabling end-to-end processes from overall vessel design to performance simulation. In semiconductors, the technological barriers of ADA software remain difficult for many nations to overcome. In aerospace, Lockheed Martin's R&D design software is central to the F-35 fighter jets development. With only a handful of companies globally capable of creating comparable software, leveraging its industrial software technological edge, the U.S. holds significant influence in global high-end manufacturing. shaping the sector's trajectory through software licensing and technical collaborations. However, in recent years, countries worldwide have accelerated the localization of industrial software. European companies like Dassault Systems are emerging, achieving substitution in certain mid to low-end industrial software sectors. Yet in high-end industrial software, the U.S. technological advantage will persist for the foreseeable future. At the aviation industry exhibition area, the massive aircraft engine model is awe-inspiring. Its sleek silver casing reveals intricate internal blades, hailed as the crown jewel of industrial manufacturing. Its development and production pose challenges akin to scaling the heavens. Globally, only 3 companies can craft this jewel: GE Aviation and Pratt & Whitney from the United States, and Rolls-Royce from the United Kingdom. The U.S. holds 2 of these positions, demonstrating absolute technological supremacy. GE Aviation's LEAP series engines are the world's best-selling narrow-body aircraft engines. By the end of 2025, global deliveries had exceeded 12,000 units, capturing 45% of the global narrow-body aircraft engine market. Pratt & Whitney's PW1100G series engines, renowned for their high fuel efficiency and low noise levels, are widely adopted by Airbus A320neo series aircraft, holding a 30% global market share. In Q2 2025, GE Aviation's revenue surged 21% year-over-year to $18.6 billion, with data streams continuously scrolling alongside models, underscoring its robust industrial vitality. This revenue growth primarily stemmed from the global aviation industry's recovery, with narrow-body aircraft engine orders increasing 35% year-over-year. In the field of wide-body aircraft manufacturing, Boeing and Airbus stand as the 2 dominant giants of the skies, collectively controlling over 99% of the global market and forming a duopoly. Boeing serves as the cornerstone of the U.S. aerospace industry. Its Boeing 737 series narrow-body aircraft and 787 series wide-body aircraft are the backbone of the global aviation market. By the first half of 2025, global deliveries of the Boeing 737 series had surpassed 11,000 units, making it the world's most delivered passenger aircraft model. However, Boeing also faces significant challenges. 2 major safety incidents involving the Boeing 737 MAX series in 2018 and 2019 led to its global grounding. Although subsequent modifications enabled its return to service, consumer trust has not fully recovered. In the first half of 2025, Boeing received 320 orders for the 737 MAX, trailing the 450 orders for Airbus's A320neo series. In the first half of 2025, Airbus's revenue grew 3% year-on-year to €38 billion, while net profit surged 85% to €5.2 billion. These performance metrics indicate intensifying competition between the 2 manufacturers. Leveraging more stable product quality and a richer order backlog, Airbus is steadily expanding its market share. Beyond civil aviation, the United States maintains formidable strength in military aviation and business jet segments. Gulfstream's business jet set the global benchmark for the premium market. Models like the G650 and G700 dominate over 30% of the high-end segment with their long range, exceptional comfort, and high speed, serving numerous multinational corporations and government agencies worldwide. Lockheed Martin's military aircraft are globally leading, with its F-35 series fighter jets ranking among the world's most advanced 5th-generation aircraft. By the end of 2025, global deliveries had exceeded 1,000 units, procured by over 20 countries and regions, making it the world's best-selling military aircraft. Additionally, Lockheed Martin's C-130 series transport aircraft and U-2 high-altitude reconnaissance aircraft hold significant positions in the global military aviation sector. Northrop Grumman excels in strategic bombers and unmanned aerial systems. Its B-21 stealth bomber completed its maiden flight in 2025, featuring superior stealth capabilities, extended range, and substantial payload capacity. These aircraft will form the core of the U.S. Air Force's future strategic strike force. The U.S. aerospace industry's leadership stems from its robust industrial ecosystem and substantial R&D investment. America possesses the world's most comprehensive aerospace supply chain, with top-tier enterprises supporting every segment from aircraft, engines and avionics to component manufacturing, forming a synergistic and efficient industrial cluster. In 2024, U.S. aerospace R&D investment reached $75 billion, accounting for 55% of global aerospace R&D spending. This substantial investment ensures continuous technological innovation. Simultaneously, U.S. government military contracts provide stable support for aerospace development. The U.S. Department of Defense's 2025 aviation equipment procurement budget stands at $120 billion, with the majority of orders going to domestic companies like Boeing and Lockheed Martin. However, the U.S. aerospace industry also faces challenges such as rising costs and supply chain instability. Global supply chain tensions have led to shortages in aircraft components, extending the delivery cycle for Boeing 787 series passenger aircraft from 6 to 10 months. Rising costs have also compressed corporate profit margins, issues that will impact the long-term development of the U.S. aerospace industry. Shifting focus from the skies to the seas. The Naval Military Exhibition Zone featured imposing models of nuclear submarines and aircraft carriers. The black nuclear submarine model resembled a giant shark lurking silently in the deep ocean, while the aircraft carrier model resembled a mobile maritime city, with carrier-based aircraft models neatly arranged on the deck, fully showcasing the majesty of the deep-sea dominator. Although the United States is not a traditional shipbuilding powerhouse, holding less than 5% of the global market share in civilian shipbuilding, it is the undisputed leader in naval military technology. Its naval military products rank first globally in both technological sophistication and performance metrics, with no other nation capable of rivaling them. Beside the model of the world's first nuclear submarine, the Nautilus, stands a plaque honoring its developer General Dynamics. The Nautilus's launch in 1954 marked humanity's entry into the nuclear submarine era, igniting a technological revolution in naval warfare. Today, the vast majority of the U.S. Navy's nuclear submarines are still developed and produced by this company. General Dynamics, Virginia-class attack submarines and Columbia-class strategic submarines are among the world's most advanced nuclear submarine models. The Virginia-class attack submarines feature excellent stealth capabilities, high speed and powerful firepower, enabling them to perform multiple missions including anti-submarine warfare, anti-ship operations, and land strikes. By the end of 2025, 28 Virginia-class submarines had been delivered to the U.S. Navy. The Columbia-class strategic nuclear submarines form the core of America's future sea-based nuclear deterrent, set to replace the Ohio-class submarines, expected to enter service in 2030. They carry Trident D5LE submarine-launched ballistic missiles with a range exceeding 12,000 kilometers, delivering global strike capability. Newport News Shipbuilding stands as the cradle of aircraft carriers. As the parent company of Gulfstream Business Jets, it remains the sole builder of all U.S. aircraft carriers to date. From the Nimitz-class nuclear-powered carriers to the Ford-class nuclear-powered carriers, all have been constructed at this shipyard. The Ford-class nuclear-powered aircraft carrier represents the world's most advanced carrier design, incorporating cutting-edge technologies such as electromagnetic catapults, advanced arresting gear, and integrated nuclear propulsion. The electromagnetic catapult system significantly enhances aircraft launch efficiency, achieving a 50% improvement over traditional steam catapults. This boosts daily aircraft sorties from 160 on Nimitz-class carriers to 220 on Ford-class vessels. By the end of 2025, 3 Ford-class carriers USS Ford, USS John F. Kennedy, and USS Enterprise will be in service, with the 4th vessel, USS Dominica, currently under construction and scheduled for delivery in 2028. Newport News Shipbuilding possesses globally unmatched technical expertise and production capacity in large carrier development and construction. Boasting the world's largest dry docks, most advanced shipbuilding equipment, and an experienced technical team, it ensures both quality and schedule for carrier construction capabilities unmatched by any other shipyard globally. The LM2500 shipboard marine gas turbine model on display also drew visitors' attention. This gas turbine, akin to the heart of a deep-sea giant whale, provides powerful propulsion for naval vessels. Developed by General Electric, it is the world's most widely installed shipboard marine gas turbine. By the end of 2025, global installations had surpassed 3,000 units, adopted by navies in over 30 countries and regions. The LM2500 naval gas turbine delivers an output power of up to 21,500 horsepower, offering advantages such as high reliability, simplified maintenance, and superior fuel efficiency. It powers key U.S. Navy vessels including Arleigh Burke-class destroyers and Ticonderoga-class cruisers. General Electric's technological edge in gas turbine engineering has further cemented America's leadership in global naval military technology. Successor models like the LM2500 Plus and LM2500G4 continuously enhance power output to meet the propulsion demands of vessels across various tonnage classes. America's dominance in naval military technology stems from the synergy of technological accumulation, R&D investment, and national strategy. The U.S. regards its naval military industry as a cornerstone of national security, consistently allocating substantial funds to technological advancement. The U.S. Navy's 2025 R&D budget reached $45 billion, prioritizing upgrades for core assets like nuclear submarines, aircraft carriers, and carrier-based aircraft. Simultaneously, the U.S. maintains a comprehensive maritime defense industrial chain. From core propulsion systems and weaponry to electronic equipment, each segment is supported by leading enterprises. Companies like General Dynamics, Lockheed Martin, and Northrop Grumman have established highly efficient collaborative systems, enabling rapid advancement in equipment R&D and production. However, the U.S. naval defense industry also faces challenges of soaring costs and a shortage of skilled workers. The unit cost of a Ford-class aircraft carrier has exceeded $15 billion, while a Virginia-class nuclear submarine costs over $3 billion per vessel. These high expenses place significant pressure on the U.S. Navy's procurement efforts. Additionally, the shortage of skilled workers in the shipbuilding industry has impacted equipment construction schedules. Newport News Shipbuilding faces a shortage of 1,500 skilled workers. Despite increased salary packages, the company still struggles to recruit sufficient numbers of experienced personnel. Looking up at the exhibition hall ceiling, satellite and rocket models from the aerospace sector hang like scattered stars, simulating the vastness of space. SpaceX's Starship model and NASA's Orion spacecraft model stand out prominently, vividly showcasing the formidable strength of America's aerospace technology industry. With NASA opening access to commercial capital, the U.S. aerospace industry has broken away from its previous government-dominated model, forming a new landscape of collaborative development between government and commercial entities. This shift has fueled another wave of explosive growth. The influx of commercial capital not provides ample financial support but also injects innovative vitality, accelerating the rapid iteration and commercial application of aerospace technologies. The latest 2025 global aerospace statistics displayed clearly on the screen. Worldwide, 325 space launches were conducted, placing 4,026 spacecraft into orbit. Among these, the United States accounted for 205 launches with 202 successes, representing 63.1% of global launches. It placed 3,652 spacecraft into orbit, a staggering 90.7% of the global total, far surpassing other nations. These figures unequivocally demonstrate America's absolute dominance in the global aerospace arena. SpaceX's Starship model stood out prominently. This sleek, silver rocket model boasts a massive frame and is the world's most powerful rocket, with a low Earth orbit payload capacity of 150 tons, far exceeding any other rocket globally. It can even deliver complete space station modules directly into orbit. The breakthroughs in reusable technology achieved by Starship are profoundly reshaping the global aerospace industry landscape. Both its first-stage booster and second-stage spacecraft can be recovered and reused, significantly reducing launch costs. According to data released by SpaceX, the cost per launch for Starship is only $20 million, far below NASA's Space Shuttle cost of $150 million per launch and also lower than the $62 million per launch cost of the Falcon 9 rocket. By the end of 2025, Starship had completed 12 test flights, with 8 successful recoveries of the first-stage booster. Recovery technology for the second-stage spacecraft is also advancing, with the first crewed test flight expected in 2026 and the goal of crewed Mars landings by 2030. Beyond Starship, SpaceX's Falcon 9 remains the world's most frequently launched rocket, completing 156 launches in 2025, accounting for 48% of global launches. Its reusable technology has reached high maturity, with first-stage boosters reused up to 18 times. Beyond SpaceX, multiple U.S. commercial space companies are rapidly emerging. Blue Origin and Virgin Galactic demonstrate strong competitiveness in distinct segments. Blue Origin's New Shepard rocket focuses on suborbital tourism, having completed 38 suborbital flights by the end of 2025. It has carried over 200 passengers into space, ushering in a new era of commercial suborbital tourism. Its New Glenn rocket targets the orbital launch market, boasting a low Earth orbit payload capacity of 45 tons, with its maiden flight scheduled for 2026. Virgin Galactic's Spaceship 2 employs a spaceplane model, launched from a carrier aircraft at high altitude before autonomously flying into space. By the end of 2025, it had completed 25 commercial flights, offering tourists a unique space experience. Traditional aerospace giants like Lockheed Martin and Boeing remain core partners to NASA, playing vital roles in critical areas such as deep space exploration, human spaceflight, and satellite development. The Orion spacecraft, developed by Boeing in collaboration with NASA, serves as the core vehicle for America's Return to the Moon program, capable of transporting astronauts to lunar orbit and ensuring their safe return to Earth. It completed its first unmanned lunar test flight in 2025, with the inaugural crewed lunar landing anticipated in 2027. Lockheed Martin is responsible for developing certain modules of the lunar lander and participates in the U.S. Artemis program alongside SpaceX and Blue Origin, supporting America's goal of returning to the moon and establishing a lunar base. In satellite development, Lockheed Martin, Boeing, and Northrop Grumman hold significant shares of the global commercial satellite market, possessing advanced technologies in communication satellites, remote sensing satellites, and navigation satellites. In Q2 2025, these traditional aerospace giants achieved stable revenue growth in their space divisions. Boeing's aerospace revenue reached $5.8 billion, up 12% year-over-year. Lockheed Martin's aerospace revenue hit $7.2 billion, rising 15% year-over-year. The explosive growth of the U.S. aerospace technology industry is inseparable from NASA's policy support and financial investment. NASA's fiscal year 2025 budget reached $38 billion, with over $15 billion allocated to support commercial aerospace enterprises' R&D and project collaborations. Through initiatives like Commercial Resupply Services and Commercial Crew Program, NASA has delegated numerous space missions to commercial entities, allowing it to focus on frontier research in deep space exploration. Simultaneously, the U.S. government positions the aerospace sector as a vital component of national strategy, setting lunar and Martian exploration as long-term objectives. Major initiatives like the Artemis program and Mars sample return missions drive continuous advancements in space technology. However, the U.S. space industry also faces challenges like space debris cleanup and intensifying international competition. The proliferation of satellite launches has led to a surge in space debris, posing threats to the safe operation of satellites in orbit. Meanwhile, space industries in multiple countries and regions are rapidly developing, achieving major breakthroughs in lunar and Mars exploration programs. Several new rocket models are poised for their maiden flights, signaling escalating global competition in space. Competition in space that challenges America's leading position. Finally, we arrive at the Internet Technology and Operating Systems exhibition area. Within the simulated data center here, rows of servers stand neatly arranged, their indicator lights flashing continuously like countless pulsating hearts, underpinning the global digital economy. The Internet Technology sector serves as the core vehicle for commercialization within the U.S. tech industry and a vital engine for global digital economic growth. American companies dominate this field absolutely, with their presence spanning nearly every segment from internet advertising and cloud computing to search engines. Google and Microsoft reign as the traffic titans of the global internet advertising market, commanding the lion's share. In the first half of 2025, the global internet advertising market reached $380 billion, with Google holding 32% and Microsoft 18% together accounting for over half the market. Google attracts vast numbers of advertisers through its global search engine, YouTube video platform, and other traffic gateways. Microsoft, through platforms like Bing Search and LinkedIn, holds advantages in corporate advertising and professional networking advertising. In the cloud computing sector, the monopolistic dominance of U.S. companies is even more pronounced. According to third quarter 2025 Global Cloud Infrastructure Service expenditure data, the global cloud infrastructure service market reached $85 billion, with Amazon Web Services AWS, Microsoft Azure, and Google Cloud collectively holding 66% of the market share, forming a triopoly. Amazon Web Services also leads with a 32% market share, offering the world's most comprehensive cloud computing service ecosystem. It provides over 200 distinct cloud services ranging from foundational computing and storage to advanced Offerings like artificial intelligence, big data analytics, and IoT catering to diverse enterprise needs. Over 1 million global businesses utilize AWS services. Microsoft Azure holds the second position with a 22% market share. Leveraging deep integration with Microsoft Office, Windows, and other products, it possesses strong competitiveness in the enterprise market. Many traditional enterprises prioritize Azure during their digital transformation processes. Google Cloud ranks third with a 12% market share, boasting technological advantages in artificial intelligence and big data processing, which attract a large number of internet and technology companies. These internet tech giants leverage their formidable technical capabilities to build distributed computing systems, using large-scale GPU computing clusters. These systems have replaced supercomputers painstakingly developed by various nations in multiple scenarios, demonstrating robust technological advantages. By connecting vast numbers of ordinary graphics cards, distributed computing systems form powerful computing clusters, whose computational power can match or even surpass supercomputers, yet at a cost of only 1/10 that of supercomputers. Google's TPU clusters and Microsoft's Azure AI supercomputers exemplify such distributed systems, achieving exascale computing power to support large-scale AI training and scientific computations. In meteorological forecasting, gene sequencing, and materials science, these distributed systems have become essential computational tools, significantly boosting research efficiency. Internet technology industry's leadership stems from early technological innovation, ample capital investment, and a robust industrial ecosystem. As the birthplace of the Internet, the United States boasts the world's most mature Internet industry environment, featuring a complete industrial ladder from startups to industry giants. The flourishing venture capital sector provides ample funding for Internet technology startups. In 2025, U.S. venture capital investment in the Internet technology sector reached $68 billion, accounting for 55% of the global total. This substantial capital infusion ensures continuous technological innovation. Simultaneously, the U.S. boasts the world's richest array of Internet application scenarios. Rapid advancements in e-commerce, online education, remote work, and other sectors have driven continuous iteration of Internet technologies. However, the U.S. Internet tech industry also faces challenges such as intensified antitrust regulation and data security controversies. Multiple countries and regions globally are strengthening antitrust oversight of Internet tech giants, with the EU having already imposed multiple hefty fines on companies like Google and Microsoft. Data security and privacy protection concerns have also drawn widespread attention. U.S. Internet companies collect vast amounts of user data globally, and their data processing practices face regulatory restrictions in multiple countries. These issues will impact the global expansion of the U.S. Internet technology industry. Operating systems serve as the foundation of the digital world, supporting the operation of all digital devices from personal computers and smartphones to servers and industrial control equipment. Every digital device relies on operating system support. The U.S. holds a significant advantage in this domain, though it faces formidable competitors. The global operating system market exhibits a U.S.-dominated, multipolar competitive landscape. In the personal computer sector, Windows and Mac OS stand as two major foundation pillars, collectively commanding the vast majority of the global market share. Windows holds 78% of the global PC operating system market and a staggering 90% share in the domestic market. Mac OS commands 17% of the global market, primarily targeting high-end user segments. Windows has become the world's most dominant PC operating system due to its excellent compatibility and rich application ecosystem. Over 80% of enterprise office computers globally run Windows. Mac OS, meanwhile, is widely favored in creative design and film production for its clean interface, stable performance, and robust security. Meanwhile, Linux has emerged as a rising force. Leveraging its open source and free nature, it has rapidly gained traction in servers and embedded devices, capturing approximately 5% of the global market. Linux's open source nature allows enterprises and developers to modify and optimize its source code, enabling precise customization for diverse scenarios. In the server sector, Linux commands over 80% market share, powering the servers of the vast majority of global Internet companies. In the embedded device sector, Linux is also widely adopted in smart TVs, smartwatches, automotive electronics, and similar products. By 2025, China's Linux operating system shipments are projected to exceed 20%, with domestic market share surpassing 10%, breaking the absolute monopoly of American systems. Chinese operating systems like Deepin Linux and UnionTech UOS have achieved large-scale deployment in critical sectors such as government offices, finance, and energy, gradually replacing Windows systems. The two major mobile operating systems, iOS and Android, are also developed under American leadership, firmly controlling the global smartphone OS market with a combined global market share exceeding 99%. Android, developed by Google under an open-source model, commands an 85% global market share and is adopted by the vast majority of smartphone manufacturers including Samsung, Xiaomi and Oppo. iOS, independently developed by Apple, is exclusively used on Apple's iPhone devices, holding a 14% global market share. Its deep integration with Apple hardware fosters strong user loyalty. In the mobile application ecosystem, Apple's App Store and Google's Google Play stand as the world's two largest mobile application distribution platforms. In the first half of 2025, their combined app downloads reached 85 billion, with total app revenue amounting to $68 billion, forming formidable ecosystem barriers. Companies dominate the direction of Linux ecosystem development. Linux distributions from American firms like Red Hat and SUSE command over 70% of the global server Linux market. Red Hat's RHEL system stands as the benchmark for enterprise-grade Linux, adopted by more than 90% of Fortune 500 companies worldwide. In commercial applications, Unix systems retain significant importance. They remain in use for core business systems in critical industries like finance and telecommunications, with IBM's AIX and Oracle's Solaris being mainstream choices in the market. In industrial manufacturing, embedded operating systems like Windows Embedded and VxWorks provide critical support. Developed by US-based Wind River Systems, VxWorks commands over 60% market share in aerospace and industrial control sectors. US F-35 fighter jets and SpaceX's Starship both utilize VxWorks systems. America's dominance in operating systems stems from decades of technological accumulation and a robust ecosystem. Developing operating systems demands substantial technical investment and long-term experience. Leveraging early technological advantages, U.S. companies pioneered comprehensive application software ecosystems, creating powerful network effects. New operating systems face significant barriers to breaking through these established ecosystems in the short term. Simultaneously, U.S. companies leverage patent licensing and technical collaborations to convert technological advantages into market influence, further cementing their dominance in the global operating system market. Despite Linux's rapid rise in specific sectors and accelerated efforts by nations like China to develop domestic operating systems, America's overall advantage in this domain remains unshakable in the near term. Stepping out of the technology exhibition hall, the city glowed brightly under the night sky. This exploration journey has made it clear that America's top 10 cutting-edge technologies stand as 10 formidable technological strongholds, underpinning the core of its global competitiveness. Yet simultaneously, the waves of multipolar competition continue to batter these strongholds, gradually eroding its advantages in certain domains. The race for technological supremacy knows no finish line. Only by maintaining innovative vitality and embracing diverse collaborations can one secure a firm foothold in the global technological tide.